What statistical test should I use? Now, in order for us to decide, we need to answer some few questions. So the first question to answer is, what is the purpose of your analysis? So for example, do you want to determine a relationship, or you want to know if there's a difference between two or more variables? So if you want to determine a relationship, for example, we can say that what is the relationship between cigarette smoking and lung cancer? Now, if you want to know a difference, we can see that what is the difference between blood pressure before and after taking a blood pressure medication. So once you have your answer, you move to the second question, which is, what level of measurement are your variables? Now, you want to know whether they are nominal, ordinal, or continuous. And I want you to know that nominal is also known as categorical. Ordinal is usually ordinal, while continuous is also referred to as a ratio or interval. So for nominal data, there are always in categories. For example, gender. In gender, you are either a man or a woman. Another example of nominal data is hypertensive or not hypertensive, infectious or non-infectious. These are categories. You have to belong to one group. For ordinal data, it's data that comes in order. For example, mild, moderate, and severe. And then for continuous, it's data that we measure on a continuous scale. For example, weight, height, and blood pressure. And once you are done with figuring out this part, the next question is, how many groups are you comparing? Is it one sample? Is it two or more groups? You have to decide that as well. And the next question is, are your data paired or unpaired? Now, a paired data is also known as matched or dependent. And we can say a data is paired when a study is conducted on an individual level, like a before and after treatment study. Let's say measuring blood pressure before and after medication. Another example is performing a surgery on the right ear and then comparing the hearing of the right ear to the left ear. So that is an individual level study because it's still the same person. Nothing that has to do with that person's characteristics has changed. And also we can have a paired data outside of an individual. And this is where we pair two people based on shared characteristics, based on similar characteristics. For example, we have three men and three women having the following systolic blood pressure. Men have 150, 160, and 171, and women have 152, 161, and 117. Then we pair men and women with similar blood pressure. So we pair 150 with 152, 160 with 161, 171 with 117. And then we decide which one of them goes into the treatment group and which one of them goes into the control group. Now, unpaired data is also known as unmatched data or independent data. And we can say a data is unpaired when the groups are independent of each other. For example, selecting blood pressure 150, 152, and 160 and placing them in the treatment group, and then putting blood pressure 140, 171, and 170 in the control group. So if you notice, the treatment group and the control group subjects are not similar. No one in the treatment group is matching anyone in the control group. And the next question is, does the data fulfill the assumption for a parametric test? Now, if your data is normally distributed like this, then you can use a parametric test. If it is skewed and you have a big sample size that is more than 30, you can also use a parametric test. But if it is extremely skewed, that is, it is not normally distributed, or it has outliers or extreme values, you can use a non-parametric test. Now, let's look at how we can actually make this decision using an example. So let's say that we want to compare the difference between before and after treatment of a paired variable measured on a continuous scale, and the data fulfills the assumption of normality. That is, it is normally distributed. We'll use a paired t-test. But if we are comparing more than two groups, let's say we collected data before treatment, 1 week after treatment, and then 2 weeks after treatment, then we can use a repeated measures ANOVA. Then let's say the data is unpaired with the variables measured on a continuous scale and with a normal distribution, then we can use an unpaired t-test, also known as independent t-test. Now, let's say we have more than two groups, then we can use one-way ANOVA. Now, let's say we want to compare the difference between before and after treatment of a variable measured on a continuous scale. But this time, the data did not fulfill the assumption for a parametric test. That is, it is not normally distributed, but it is symmetrical. Then we can use a non-parametric test like a Wilcoxon signed rank test if the design is paired. And if the data is ordinal or continuous but not symmetric in nature, then we can use the sign test. And if we have more than two groups or more than two measurements, then we can use the Friedman test. And if the design is unpaired and the data does not fulfill the assumption for normality or contains extreme values, or it is measured on an ordinal scale, then we can use the Mann-Whitney test. And if we have more than two groups, we'll use the Kruskal-Wallis test. Now, if we want to compare the difference or investigate a relationship between two variables measured on a nominal scale, we can use McNemar test if the design is paired. And when we have more than two groups, we can use the Cochran-Q test. And if the design is unpaired, then we can use a chi-square test, even if we have more than two groups. And then if we want to analyze for a relationship between two variables measured on a continuous scale with assumptions for a parametric test fulfilled, then we can use the Pearson correlation to know how strong the relationship is. But if we want to predict or estimate how much the independent variable affects the dependent variable, then we can use linear regression. And if the data did not fulfill the assumption of a parametric test, or if one variable or both variables are ordinal, then we can use the Spearman correlation. Now, all the tests that we've been choosing has to do with two or more samples group. But what if you have one sample group that you want to compare against a population or against a hypothesized value? Let's say, for example, we took the weight of 5 adults to be 50, 60, 70, 75, and 69. So the average weight will be 64.8 kg. Now, if we want to compare the average or the mean weight against a population weight, which is, let's say, 76 kg, to see how it differs, we can use a one-sample t-test if the data is measured on a continuous scale and fulfills the assumption for a parametric test. But if it doesn't fulfill the assumption for a parametric test on a continuous scale, or it's measured on an ordinal scale, then we can use the Wilcoxon signed rank test or the sign test. And if our data is on nominal scale and we want to compare a sample proportion against a hypothesized proportion, then we can use a one proportion z-test or a chi-square test. As promised, feel free to visit the Sage Research Method link on the screen, and I'm also going to put it in the description to answer some few questions and get a suggested statistical test to use for your research, and I'll see you in my next video.